Good morning, everyone. I'm Dr. Elizabeth, Assistant Professor, Selection Grade, Department of AEDS, K80, Kalingar Karnanity Institute of Technology. Today, we are going to discuss regarding implementation of Boolean function using logic gates. Logic gates. First of all, it is very important in digital logic. These are all very basics. First, we should understand why we are studying and what is the purpose we are have to use. That everything today we are going to discuss. First of all, logic gates means why I have to study, because you have to construct digital systems. Nowadays everything is a digital oriented, zeros and ones. Even if you are using computers, if you take in every automated way, we are having the digital oriented only. So for that only, these logic gates play a very important role in understanding how to construct a digital systems. So before moving into this, how many gates are available? First one is AND gate, OR gate, NOT gate, NAND gate, then NOR, XOR, and XNOR. So totally we are having basic gates as the seven gates are available. So first we will discuss what is meant by AND gate, then OR gate, NOT gate, NAND gate, NOR gate, XOR gate, XNOR gate. So here we have to know the basic diagrams as well as the truth table, how we have to construct that, everything we will discuss now. So first I'm moving into AND gate. So AND gate. So look at this diagram, basic diagram. So first of all, you have to give the input A as well as B as your input. So through that, AND gate means it should be drawn like this D shape. So usually AND gate we have to use the D shape. So that D shape you have to mention it. So after passing your input, what is the output you will get means A into B. Y means that is nothing but it is the output. Y is equal to A into B. So ungate, always remember your output should be A into B, because these, through this output only you are able to know the truth table very easily, how we are calculating. If for example this is 0, this is 1, this is 2, this is 3. So whenever you are constructing a truth table, you should know this one 8421 combination. So based on that only we will write. This is for 4 bits I'm talking. Just we here we have taken only 2 bits. So 2 1 combination. So first 0 0. 0 0 means your input is 0. A into B means obviously you can do a normal multiplication. So 0 into 0 you will get 0. That is the first thing we have given. Next 1. 1 means 0 here will be there. 1 in the presence of 1 you have to put 1. So 0 into 1 you will get 0. Then afterwards 2 1 0 combination. 1 into 0 you will get 0. Then finally 3 1 1. So 2 plus 1, that is the meaning of 3. So 1 1 we are placing. So 1 into 1 you will get 1. So in this way only we are doing for AND gate. So what is this IC pin? If you take an IC pin, so 14th pin will be a power supply for you. 7th pin will be your ground supply. So for example 1 2 you are giving means it's your input, 3 is your output, 4 5 it's your input, 6 will be the output. You maybe have, ma'am, where is the sound 7? I already mentioned 7 is used for ground, that is why we didn't mention here. Then then afterwards 8 9, then sorry 10 9, 8 will be your output, then 13 12 11 will be your output, 14 I already mentioned that is used for power supply. So this is the AND gate. I hope you understood very well regarding AND gate. Next we are moving into OR gate, same thing only. Here the very important thing that in your diagram you have to mention like this shape. So R means always you have to mention this shape. And means it's a D format. R means you have to mention like a flying shape. A, B is your input. Output is A plus B. Remember, AND gate, this is very basic. A into B. But R gate, A plus B. So always remember, this is very important, because while you are constructing NOR gate and everything, at the time these basic things should be always recalled. So AB, your output will be A plus B. Already I told you how to construct the truth table in the AND gate. The same thing we are going to be repeated over here also. So this is for 0, this is for 1, this is for 2, and this is for 3. So meaning of this one is 2, 1. I already told you. So 0 means 0, 0, because your A is also 0 and B is also 0. So y is equal to A plus B. In normal addition, how you will do, the same thing only you are going to be performed here. So 0 plus 0, you will get 0 only. Then afterwards 1. So in the place of 1, we are placing 1. 2 is as a 0. So 0 plus 1, you will get 1. Then afterwards, in the place of 2, you are placing 1. 0 as a 0 only. 1 as a 0, sorry. Then afterwards, you are getting 1 plus 0 as the 1. Then 1 plus 1, obviously don't put 2. In digital, it will never come, because digital means zeros and ones only. So 1 plus 1, you should remember only 1 only. So this is called as the OR gate. So here also we are having IC pin 7432. 1 and 2 you are giving as your input. 3 you are getting output. 4 and 5 you are giving as your input. 6 you are getting as the output. What about 7? If you ask, it means 7 is used as the ground. And 10, 9, 8 is your output. 13, 12, 11, same thing. 14 is your power supply. And talking regarding, this is the IC pin. At the time we will use in the combination of OR gate. Practically you can do that one. Then third gate we are moving as the NOT gate. I hope up to and OR you may be understood very well. Always remember in your mind, AND means A into B, OR means A plus B. Next, NOT gate. NOT gate is very simple and very easy gate also. You have to draw a triangle format, and afterwards you have to put a one small circle. That means if you are giving A, if you are passing into the NOR gate means you will get the output as a bar. That means 0 if you are passing, you will get the output as your 1. Suppose if you are passing 1 means you will get the output as the 0. That is known as the NOT gate. So, simple diagram, only one input is enough for you, because you are going to get only one output. So, same thing, 0 if you are passing, 1 you will get it, 1 you are passing, 0 will get it. So, it's very easy gate. So, basic gates and are then not. That is what I have mentioned here. What is the IC pin you will use to over here means 7404 you will be used over here. So 1 and 2 if you are giving, 3 and 4 you will get, 5 and 6 you are giving means 9 and 8 you will get, 11 and 10 you are giving means you are think you will get as the 13 and 12. So this is used for the IC pin. Next we are moving into NAND gate. So already we have studied regarding AND gate. AND gate means I already told it's a D shaped. Here one circle you have to add it. That means not plus AND gate. That is the meaning of the NAND gate. So A, B if you are giving means you will get opposite. Already AND means I told A into B. So here just only one not you are going to be added over here, that is bar. Y is equal to AB bar. So this is the output of NAND gate, you will get it. So we can discuss now truth table A, B, Y. So first you have to do it 0 into 0. That will come for AB. First you have to take AB, 0 into 0 you will get 0. But I already mentioned it's a NAND gate, so bar. So if you are getting 0 as your output means you have to convert as a NAND means it will come as the 1. Then 0, 1 if you are giving means obviously you know it will come as the 0, because A into B 0. But if you are taking NAND, that means not means inverter. So 1, 1, 0, you will get as the 0 only. Your output will become as the 1. So how means A into B, you will get 0, 0, 1. Just you have to take as the not 1, 1, 1, then 0. That is the simple remembrance of NAND gate. So here we are using IC pin as 7400. This is called as the IC pin. Then 1 2 is your input, same like 3, then 4 5 6 10 9 8 13. So 14 will become as your power supply, 7 will become as your ground connection. That is why we didn't mention in the IC pin. Practically we can do it. So next gate we are moving as the NOR gate. Already we have studied regarding OR gate. So OR gate I already told A plus B. Now we are going to take as the inverter of this one. Very simple, you can remember us. If you are remembering OR and AND gate means you can design NAND and NOR gate very easily. So A, B your input. So already OR gate means it's a flying shape. One thing you have to add, that is NOT gate, then it is becoming automatically NOR gate. Y is equal to A plus B, the bar. Now if you taken over here means, so already we have designed for A plus B means 0 will come, 1 1 1. This is for A plus B. A plus B, A plus B. Now A plus B bar means you have to take ulta. 0 means 1, 1 means 0, 1 means 0, 1 means 0. Same thing only we have designed for NOR gate. So here what is the pin we are using means 7402. So just we are taking ultra format of G3 2 as your input means 1 will become as the output. Same thing which I have explained before for OR gate as well as AND gate, how the pin has been enabled. Same thing only we are using for NOR gate. Next we are going for XOR gate. So XOR gate, already you know this is OR gate. X means you have to use one more flying shape, half of the flying shape. So A, B, then this is X, this is called as the OR gate. So what is the output you will get means Y is equal to A, A XOR of B. So this symbol is called as the XOR symbol. So how can you can split up and you can write it down means you can derive means A XOR B. A B bar plus B A bar. So this is the full form of the XOR. A B bar plus B A bar. Just remember it. So as per things we are going to draw the truth table A B. So 0 0 you are going to get the output as 0. 0 1 you are going to get the output as 1. 1 0 you are going to get as the 1. 1 1 you will get as the 0. So this is the combination of the A B bar plus B A bar. So you can write over here also very easily 0 B bar 1 1, then plus B is some way 0, then A bar will come as 1. If you make a combination means you will get as the 0. So this is called as the XOR gate. What is the pin we will use over here means 7486. Same thing, 1 2 3 as your input, 1 2 and 3 is your output. So the same combinations we have made up to 13. 14 will act as the power supply. So that is what here we have explained over here. Then we are moving into XNOR gate. XNOR gate means, so already we have studied NOR gate. So it's a combination of NOT plus R. Now what we are going to do? X NOR. So we are going to add X. So A, B, one flying shape. That means half of the flying shape. Then this is R, this is NOR. So this is becoming NOR gate. So what is the thing you will get means Y is equal to A X NOR. This is now called as the A X NOR B. So how you can split A B plus A bar B bar. So we can write as the A XNOR of B Like that we can make a simplification of x nor. So a b y, 0 0 1 you are getting, 0 1 0 1 0 0 1 1 1. So this is becoming as the XNOR gate. So now we have discussed the basics of AND, OR, NOR, NAND, XOR, XNOR. Like that we have discussed all the basic gates. Now we are going to study the universal gates. Already we have discussed NAND gate as well as the NOR gate as the universal gates. Why we are calling means by using these gates you can make any gate as a combination, and you can bring new gates also. That is why we are calling as the universal gates. Now we can study regarding NAND gate. In NAND gate, what are the things we are having? Different type of functions: not function, unfunctions, or functions we are having, and then NAR functions we are having. So now we will study one by one why we are calling this one. So not function, just simply we are adding not gate. So y is equal to ab bar. That means how we are using De Morgan's law we are applying over here. So De Morgan's law, x bar, if it is there means it will become as the x bar plus x bar. Finally you will get the output as the x bar. So how we have got this means, simply we have to remember De Morgan's law. Then under function a b, same thing, we are including one not. So y is equal to a bar bar b. So whenever you remember bar bar is there means both will cutter, and you will get a simple equation ab. Then R function we are having a b. So we are including one not, and then afterwards R function we are including. So how you are getting means, that is what I said, it's a De Morgan's law. A b bar is equal to a bar plus b bar. This formula we have applied over here. A bar bar plus b bar the whole bar. So finally if you split it means you will get a bar bar plus b bar. So bar bar is getting cancelled. Finally you will get a plus b. So this is our function. Then NOR function. So here we are including NOT gates as well as one of the AND gate, that means NAND gate. Then afterwards again we are including the NOT gate. So now you are getting a plus b the whole bar. So if you taken means a bar bar b bar. Sorry, a bar b bar the whole bar. So you will get a plus b, you will get bar bar will get cancelled. Then afterwards NOR universal gate. Here also same thing, not function, OR function, AND function, as well as NAND functions we are having. So we'll discuss one by one. Not function we are taking as the OR gate. Then afterwards we are including one not. You get a plus b the whole bar x plus, so just ulta. NAND how you have studied, it's the same thing you are going to study for NOR gate. So x plus x the whole bar, you will get x bar. Everything is a De Morgan's law. Then afterwards OR function a b, then a plus b the whole bar, you are getting a plus b the whole bar, you are getting a plus b. Then afterwards AND gate, one NOT gate you are using, then OR gate, y is equal to a plus b bar bar the whole bar you are getting. So I said it's a De Morgan's law, y a bar plus b bar, a bar bar into b bar. So bar bar will get cancelled, a into b you will get it. So the same thing we have applied for AND function. Then finally we are coming as a conclusion for our topic NAND function. A b, a bar b bar. Then afterwards on R function, not function we are using, y equal to a into b, y is equal to a dot b the whole bar. So that's the thing, this is the function of NAND function. So thank you everyone for watching my video. I hope you like, if you have any queries means you can comment, I can give the answer. Thank you once again.